this is gonna be one of those topics, guys, that this is a little more abstract than it's a little more abstract than the equations and inequalities. So if you have questions, guys, make sure you ask. I'm gonna try to start as basic as we can and then work our way up to the more difficult stuff. Okay, so guys, let's do some. I gotta change the screen. Hold on a second. Let's do some review first. Okay, I like starting simple and working our way up. Okay, um, let's talk about some of the things that you know. Let's see what's up here. Is that better? It's not as bright. Okay. All right. Now, over here to the side, guys, I'm going to do like a little review. Okay. Um, guys, in math, when you hear the word domain, what does it make you think of? Think about all the math things you've taken. And if I say, what's the domain of a function? What is it saying in a nutshell? Anybody have any idea? If I'm talking about the domain of a function, okay, if I'm talking about the domain of a function, then I am talking about the x values of that function. Okay, that's what I'm. If I say what's the domain, if I say what's the domain, all I'm asking for is the x values. Okay, most of the time with your functions, guys, is the x values that the function covers. Okay, or the function crosses. Okay. Um. Now remember, domain is the x values. Okay. Now remember, x values. The x values are are on the horizontal axis of the coordinate plane. And guys, this is going back to very basic, simple stuff. When you first learn the coordinate plane, I think it was probably sixth grade. When you first started plotting points, your teacher told you you go this many in the x direction, you go left or right. Okay, if your x values are negative, you go left. If your x values are positive, you go right on the x axis. Okay. Um, so they are horizontal. Okay. All right, now let's talk about the range. Now, if the domain is the x values, because usually domain and range always come together, okay? What do you think the range of a function is? So maybe some of y'all know that, just don't want to say it. But it is the y values, okay? It's the y values that the function covers, okay? The y value the function covers. Okay, y values. Y values are on the vertical axis of the coordinate plane. Guys, going all the way back to when you were in 6th, 7th grade, when you were plotting points for the first time. The teacher said if you were given a point, say you're given a point. Now, guys, everybody knows that's x and y, right? Well, the teacher will tell you, well, to plot this point, you're going to go 3 to the right because that's the x value. Okay, and then to plot this point, I need to go 4 up. Okay, and so in the vertical direction, I go up. Okay, and guys, I want to start simple with this because this is the part that a lot of students don't get very much. I don't really understand it. Okay, once you start applying it. Okay, now let's talk about absolute value functions for a minute. We're gonna get very basic. We're gonna start with the very basic stuff about it. Okay, an absolute value function. Its graph looks like a V. That's what it looks like. Okay, when you graph it. So if you're doing if you have a set of functions there, and you're trying to pick, and it says which graph shows the absolute value function, you know it's going to be this one because it makes a V. Okay, all right. It also can be. It can go. It can open down like that. Okay, both of those are absolute value functions. All right. Um. All right. Now, let's talk about how to write an absolute value function. Okay, this is called vertex form of an absolute value equation. Its form is y equals a times the absolute value of x minus h plus k. Okay, that's his vertex form, guys. You need to make sure that you understand and know how to name all the parts. Okay. All right. Now your vertex, guys. Vertex should sound familiar going back to quadratic functions. Okay. The vertex is always the opposite of h in k. So if I want the vertex of one of these things, all I got to do is look at it and pick out if the h is positive, it's going to be a negative. If it's negative, it's going to be positive. And then whatever the k values, I write that down. Okay, but it'll make more sense when we do some examples too. Okay, so that's the vertex. All right. Um, Now let's talk about each part of this. Now, the A, okay? The A tells us a few things about the function, okay? Just by doing a visual, just by looking at it, it can tell us a couple things. If A is a positive number, okay? If A is a positive number, that tells us that the absolute value function opens up, okay? So if it's a positive A value, it opens up. If the A is a negative number, that tells us it opens down, okay? So guys, if it opens up, it's going to look like this little sketch here. It's going to open up like that. If it opens down, it's just going to be the opposite. It's going to look like this. And we can tell that just by if the A is positive or negative. Okay? Now, let's talk about this part. Well, I got a couple more things about the A. Okay? If the absolute value of A, guys, when we take the absolute value of a number, can it ever be negative? No, it can't be negative, right? Because that absolute value is the distance from 0. So if I take the absolute value of A and it is greater than 1, it does what we call stretch. Okay? It stretches. This is the same thing as the square root function and the quadratic function you did in Math 2, the A value. A lot of these will be just the same as just a different function. All right. Now, if the absolute value of A is between 0 and 1 or a fraction, it's going to do what they call compress. And guys, in everyday terms, if it stretches, that means it gets skinny. It gets skinnier. As A gets bigger, the gap in this thing gets skinnier and skinnier. Okay? If it compresses, the smaller that fraction gets, the wider it goes from being this till it gets wider and wider and wider. If you have the smaller the fraction goes towards 0, the wider it gets. Okay? Okay, so guys, we covered the A part. Guys, make sure you understand this stuff, okay? And once we apply it, it'll be a lot easier to remember. Now, I'm going to draw this up here, or write the same thing out again. All right, so now, guys, we know what A does. It's positive opens up, negative opens down. It also tells us if it stretches or compresses. Now, the second part is the absolute value part, what's inside, okay? Now, guys, this part is our horizontal movement. Okay, so that part in the absolute value bars tells us if the horizontal movement, whether it's left or right. Well, how do we tell? I'm gonna tell you that now. If it's absolute value of x minus h, it moves If it's x minus h, guys, it moves h units right, which means whatever number h is, that's how many units it's going to move to the right. It's actually opposite of what you think. Okay, you would think since it's minus, it's going to go to the left, but it's actually opposite. It's actually opposite of what you think. Now, guys, if x minus h moves it to the right, what do you think x plus h is going to do? Okay, well, this is horizontal movement. If you don't move right, you're moving what? Left, right? It's got to be moving left. So if it's x plus h, it tells you it's h units to the left. Whatever that number is, that's how many you move to the left. All right. Last but not least, y equals a absolute value x minus h. The K, we've already got, we know A tells us what it, if it's stretched or compressed, it opens up or down. X minus H tells us our horizontal movement, whether it's plus or minus. Okay? The K part, it's going to tell us our vertical movement. Okay? And guys, this is going along with the transformations. I'll do domain and range when we graph it because it's much easier to see. The K tells us our vertical movement. Now, K stays true to its sign. If it's plus K, that's K units up. So if it's plus K, that's K units up. What do you think minus K is? Come on, guys, y'all asleep at the wheel on me. K units down. Awesome. All right, guys, so that's all of your transformations. Okay? You got your A value transformations. You got your horizontal transformations. You got your vertical transformation. That's all you really need to know. Okay? Now, we know what domain is. We know that domain is the x values of our function. And as they move in the horizontal direction, we know that the range is the y values of our function. And they move in the up and down. I'm going to leave that up just for a minute, guys. Make sure you get it copied if you like. Guys, I will post this on these notes on Canvas. In case you do miss something, you could always go back and look at it. Okay, so if since we have transformation stress on the brain here, guys, these are going to be our transformations. A stands for A value transformation. What do you think H stands for? Horizontal, right? And V is vertical, right? That's what those stands for. Okay. Now this is my A value. It's a -1. Okay. It's a -1. Just knowing that this is a negative. What do we know is going to? What do we know about our graph? Just knowing that that's a -1. Looking at your A value transformations at the bottom. Well, first off, is it going to open up or down? It's a negative. It's going to open down, right? It's going to open. It's going to open down. Okay. Now, the H value. Guys, remember, this part represents our horizontal movement. If it's x minus 2, I'm going to move 2 units which way? Think opposite. 2 units right. Okay. All right, last but not least, V is our vertical. That is our K value. This is our K value. Is it going to be 4 units up or 4 units down? 4 units up. So that's your transformations. Let me erase this right here so we don't get confused. Now, guys, without graphing anything, can anybody tell me what the vertex of this absolute value function will be? Good, Jeremiah. 2, 4. Guys, remember, it's always, if you look at your notes, the vertex is always the opposite of the H and the K. Well, if this is a negative 2, then that's going to be a positive 2. And then the Y value is the K value, so that's your vertex. Good job. All right, so if we plot that, 2 up 4, there's our vertex. Guys, that's going to be the highest point here because we know it's going to open down, so we know it's going to open this way. Okay, so it's going to open this way. Now, guys, you only have to do, I'm going to show you on this one, this how to do it. You won't have to do it on any of the others. I just want to make sure you know how to do it. Okay? All right, so say this was a test question. What I want you to do, if I gave you a table, okay, this is the X column, Y column. I want you to put your vertex in the middle. Okay? 2, 4. That's my vertex. So now I got that straight from the, Jeremiah told that straight from the equation. Okay? Now, what I want you to do is I want you to go 2 in the negative direction. That doesn't mean they're going to be negative numbers, but I want you to go 2 in the negative and 2 in the positive. Okay? So now that's going to be 1, 0. Guys, it's 2, 1, 0, 3, 4. Okay, that'll give you enough to graph. All right, now, guys, you can go back and plug it in for X, but I'll let the calculator do that for me. Okay, so if I get my T84, there it is. All right, I think this is still, it is. All right, so if I type it in, if I type the function in, I type it into my calculator in Y1, okay? By the way, guys, shit. By the way, if you want to know where your absolute value is, your absolute value, if you hit math and you go over to the number section, the first entry is your absolute value, okay? So that's the first entry. That's how you get to your absolute value. Okay? Alright. So I graphed that. There's what my graph looks like. Okay? I'm going to go to second table. Guys, notice here is my vertex, 2, 4. And I know that by finding it when Jeremiah told us what the vertex was based on the H and K value. Okay? Now, so it says here, I'm going to just write down the corresponding Y value. So it says 1, 3, 0, 2, and 3, 3, and 4, 2. That's all you got to do. Okay? You guys basically just find the numbers. Now, if I graph this according to my table here, be 1, 3, 0, 2, 3, 3, 4, 2. So, guys, that's about all you need to graph. So if I trace that, okay, there's my absolute value function, guys. Notice it makes a V. Okay, notice the shape of the graph. Now, let's talk about domains for a minute. Guys, let's go way back when you first started learning anything about geometry in probably in elementary school. If a line has an arrow at the end, what does that tell you about that line? Right, never ends. Good, Jeremiah. It never stops. It keeps going. Okay? Now, going based on that, this thing's going to keep going down. If it never stops, it's going to go to what mathematicians call negative infinity. Everybody understand that? It's going to go to negative infinity. This one will also go to negative infinity because it's open and down. It's going to go down to negative infinity. It can't go to positive infinity because it's going the wrong way, right? Now, let's talk about now, based on what Jeremiah said, which is correct, if this thing keeps going, let's talk about our domain first. If this thing keeps going, guys, because it's going in a up and down direction and a side to side direction, because it's going like a southwest and a southeast direction, right? Will it cover all the x values on the number line if it keeps going forever? It will, right? Because it's going right to left as well. Your domain then will be negative infinity. Because guys, if I go this way, if I go and never stop, that goes to negative infinity, right? If I go this way, where do I end up? Now, guys, remember, I'm on the as far as my domain goes, I'm talking about the x values, not the y values. If I keep going to the right on the number line, where do I end up if it never stops? Positive infinity. Guys, that is the domain of all your absolute value functions. So if you're asked that on the test, it's going to be that every time. Now, guys, on the next unit, we're going to do piecewise functions. The domain will change a little bit, but we'll cross that bridge when we get there. Okay. Now, our range. Guys, when we do, this is called function notation. Okay, interval notation. Excuse me. When you do interval notation, this is how it's got to be. Guys, why it's got to be this way, I don't know. I'm just telling you what the way it's got to be. It's got to be small, comma, large. The smallest number's got to be on the left, a comma, largest number. Okay? Now, guys, looking at this, the guys, everybody agree that this thing goes to negative infinity, right? We established that here. Okay? But will this function go to positive infinity? Or does it stop somewhere? It stops at my vertex, right? As far as the y values go, it goes up. So we know that it goes from negative infinity to the y value of the vertex. Why is it not 2? Why do I not put 2 here? Why is it 4 and not 2 on my range? Because range deals with what? Y values, right? The range deals with y values. So I don't care about the x values when it comes to my range. All I care about is the y value. So it's going to be negative infinity to positive 4. And guys, I'm not really going to be picky about it, but it should have a bracket like that instead of a comma or a. I'm not worried about this. This is just mathematically correct. I'm not really worried about it. If you want to do it with the parentheses, I'm happy with that. All right. Now, guys, what I'm going to do, I've been talking for a while. I probably done bored you to death because I'm bored to death too. Now, well, guys, what I want you to do, I want you to take number 2, and based on all the notes that we've taken in the example here, I want you to see what you can do with number 2. Guys, now listen to me. This is what I want you to do. I want you to do as much as you can. All right? What I don't mind helping you. That's not what I'm getting ready to say. But I want you to try to do it on your own, and then we'll come back together and do it do it together. Okay? So don't ask me, Johnson, I don't know what to do. Do as much as you know how. All right? And then we'll fill in the blanks when we come back together. But please try to do what you can. Don't sit here and say I can't do it because you're too lazy to do it. All right? I'm going to pause this video. All right, so now guys, I'm not gonna go like step by step because we already went over everything. Okay, so my transformations, my A, my horizontal, and vertical. Well, guys, notice that A is a positive number. Okay, A is a positive number. So my A is a positive number. All right. All right. Now, that's a positive 1. Now, guys, you can put stretches by 1, which it really don't stretch or compress. But if your A value is a positive 1, if your A value is a positive 1, then you actually don't have you don't actually have an A value. You would just put none. Because guys, remember, if the absolute value is greater than 1, it stretches. If it's a fraction between 0 and 1, it compresses. Notice that 1 is not either one of those. Okay. Also, it's not negative, so it don't open down. Okay, reflect down. Okay. Now, the horizontal part, guys, remember, is the inside of the absolute value. What'd y'all get for the horizontal movement? 1 left. Yes, 1 left. Good. All right, so 1 left. All right. And what about your V? 3 up. Okay. Good, y'all. Now, without having to graph anything, what did y'all get for a vertex? Negative 1, 3. Good. Let me fix that up a little bit. All right, so negative 1, 3 was my vertex. Okay. All right. So we know my vertex is negative 1, positive 3. And we know it's going to open up because it's a positive 1. Okay. So now, if we put that in our calculator, so y equals, going to clear that out. Absolute value, that's going to be x plus 1. Come out of the absolute value plus 3. Okay, so that's my graph. It should go up. There you go. All right, now vertex is 1, 3, so I'm going to go to my table. Excuse me, negative 1, 3. And guys, what I'm going to do, I'm going to graph it. Guys, you don't have to make a table every time. That's up to you. Just know how to read a table. Okay. Negative 1, 3 is my vertex. It's negative 2, 4, and negative 3, 5. That is your you're in your negative direction, and in your positive direction, it is 0, 4, 1, 5. I'm gonna go ahead and go another one, guys, since I've got it. You didn't have to, but I'm gonna go ahead and go another one just to make it graph better. All right. Put little arrows on the end. All right. What did it? Somebody tell me what's the domain of this function? What's it going to be probably 99.9% of the time? Negative infinity to positive infinity. Guys, remember the domain is left or right. Okay? Left or right, remember that thing keeps going. Okay? That function keeps going, so it's going to cover all my x values. All right, now, we know that this thing goes to positive infinity because it opens up. So, guys, knowing that it goes to infinity and knowing that interval notation is like this. Well, I have to calculate it now. We know that interval notation is small, comma, large. That's where you place your numbers. Guys, automatically, since we know this thing is going to positive infinity, I can go ahead and put my positive infinity here. Because, guys, there's no number larger than infinity. Okay, I just know that because that's where it's going. Okay? Now, what is the smallest number in my range? Just blur it out, somebody knows. This is your range, right? Range deals with the y values, right? Your smallest number in your range will always be the y value of your vertex. Guys, your range will always be the y value of the vertex and negative infinity y value of the vertex or y value of the vertex positive infinity. It's always going to be one of those two. That's your domain and your range. Okay? All right, I think that's it, ain't it? Yep, vertex. We got our transformations. We got our vertex, domain, and range. And then we graph it. Is anybody struggling with anything? Guys, tomorrow is plan day. Well, that's what they call it. So if you guys are struggling with this, if you will email me, I can do a Google Meet with you. I'll send you a link. You probably won't see me. You'll see the camera. Okay. We'll do a Google Meet, and then I can go over some problems with you. All right. Now, let's do this. Now, guys, the main reason don't quote me on this, I got to look again. But the reason I want to do this is because on your IXL, you have to graph an absolute value function. You got to give the domain and range, and you got to give the transformations. Okay. Now, stop. Okay. Now, guys, this is like what they call set builder notation. Let me. Okay. Now, guys, another way of writing. See this selection right here, all real numbers. That and negative infinity to positive infinity is the exact same thing. Okay. Now, what is the domain of this function? Now, what's the domain of 99.99% of all absolute value functions? And which one represents that? It's the same way of saying a different way of saying the same thing. All real numbers. Okay. All right. Now, guys, be careful because it says what is the range of this function. Now, range deals with y values. Okay. Now, guys, they didn't do this is what they call set builder notation. Okay. The y up front just tells you what variable you're working with. This tells you the range of the function. All right. Now, guys, if you think about it, the vertex here is 0, 0. Okay. So, guys, remember your vertex will always have the y value of the vertex. Your range will always have the y value of the vertex in it. Okay. So now, guys, automatically, if my vertex is 0, 0, I know good and well this can't be right. because it does not have the y value of my vertex. Everybody understand that? Okay, so we know it's one of these two right here. Well, guys, if this thing opens up, is it covering y values greater than 0 or less than 0? If it opens this way, up. It's greater than, right? Because as you go up, the y values get bigger. Okay? So this is y values greater than or equal to 0. Should be real easy. What's the domain of this function? All real numbers. Somebody tell me what the vertex of this function is. What's the vertex of that function? Somebody said it. What'd you say? Negative 5, 0, right? That is my vertex, right? Now, if I am dealing with the range, what values am I worried about? X's or Y's? What's the range? Range is your Y values, right? Now, if we said that our range is, our vertex is negative 5, 0, then guys, we automatically know that this one and this one can't be it because it does not contain the Y value of the vertex. It's got to be this one or this one. Well, guys, if that's opening up, is it going to be greater than or less than? Greater than. Does anybody have any questions about that? Everybody good? Okay. All right. I went around the long way here. Guys, graphing absolute value, that's going to be pretty easy. All you do is start you a dot and bring it up to the next dot, and then there you go. I mean, you might have to move it around a little bit, okay? But the graphing part's pretty easy. You just plot a dot, and then that's a negative, so that's going to be here. All right, but does everybody understand how to graph now? All right. Last but not least, the graph shows g of h, which is a translation of f of x equals absolute value of x. So, guys, what that's saying is what is g of h? This is g of h here, the purple line. Okay, and it's a translation of the parent function. Okay, write the function rule for g of x? Well, did it go anywhere in the horizontal direction? Did it go left or right? Well, first of all, we got to know what the parent function is. Guys, I just want to make sure you guys understand this because alright. Guys, see that f of x equals absolute value of x? Okay, guys, f of x equals the absolute value of x. This is called the parent function. Now, a parent function is very, very simple. It is a function, it is an absolute value or whatever kind of function you're dealing with that has no transformation. moved up 8 units, does everybody understand where I got 8 units from? Does everybody understand that? If I move up 8 units, where do I need to put the 8? I moved up 8 units. Isn't that the K value? Because you move up or down, that's the K value. If I move up, well, 8. That's where you put that number. Now, guys, what I would do, this is what I would do if y'all here with me. I would choose another point. Okay? Now you know that this right here, we know this because of where the vertex is 0, 0, 0, 8. So what I would do is pick another point it goes through. Another point it goes through is 1, 9. For time being, guys, I'm just going to put an X right there because I don't know for sure if it did not go horizontally, right? It did not go horizontal, so I know this is just X. All right, so now, if I put a 9 here, guys, that's the Y value, right? The X value is 1. What's the absolute value of 1? Somebody put it like this. 1, right? 1 plus 8 is 9. Does that tell me that's the right equation? It does. That is your equation. Guys, the best thing to do too, guys, I have my phone on me all the time, and I answer emails up till about 9 p.m. If you get home and you see that you can't get it, email it to me, and then I'll try to write it out on paper and send it back to you. Okay? So, it's going to be g of x, come out of the absolute value, plus 8. There you go. Okay? Guys, make sure though, that, because if you start getting them wrong, you may have to go back and start you an equation. Okay. All right. So guys, what I'm going to do? Does anybody want to see another one of those? So, man, it's y'all's time. I know how to do this, right? Okay. So I'm going to stop right there because I don't want to bore you to death. If you want to finish this stuff, you can. All right. And guys, when you get this finished, make sure you submit it on Canvas. Okay. Don't sit.